Okay, so we're going to start off with the cleaning head comparison. On the right is the Blue Square cleaning head, and then on the left is the new A&A G4V. So what we're doing is simulating real-time pressures you would see in a swimming pool application. We're running about 12 pounds of pressure. In fact, I'll come around here real quick just to validate that. You can see we got just about 11-12 pounds of pressure. Okay, so as you can see with the Blue Square cleaning head, we have a significant amount of bypass. The bypass being the water coming up and around the nozzle as opposed to out of the nozzle cleaning the pool. This is directly proportional to the efficiency coefficient of the head. Okay, so this is the Blue Square head. So what we're going to do is we're going to switch our valve, and we'll switch it over to the G4V. Okay, we're just going to water down the park here. So you can see with the G4V, you also have a degree of bypass, but not nearly as much as the Blue Square. Again, validating the pressures. We're at about 12 pounds of pressure, and you can see we have little to no blow-by. This is primarily due to the stabilizer that we've designed into the new G4V head. Okay, so there you have it, a direct comparison of the Blue Square and G4V cleaning head. Now we'll go ahead, shut it off. We'll change out our test setup to attach the valves and do a direct comparison of the valves. Okay, so we've gone ahead and attached the valve portion of our test configuration. On the right side you'll see the A&A actuator valve, and then again on the left side the valve manufactured by Blue Square. Okay, one of the things we've done is we've set this test jig up such that we're simulating 3 heads on a line, and we've done that by drilling out the corresponding orifices in each port. Okay, and you'll see here, see if I can get an underside view of this. You can kind of see where we've drilled out the holes for the A&A valve, and then we've also done the same here for the Blue Square valve. Okay, this simulates a real life scenario of 3 heads on a line in a swimming pool. Okay, so we're going to go ahead and get started. The first valve we'll be showing is the A&A valve. Okay, Jep, ready when you are. Okay, so we're in prime mode right now. We'll give it a few seconds and it'll throttle back down to normal operating mode. So while we're waiting for that to happen, I just want to make note of a couple of things. Number one, it's important to note that all valves have some type of bypass. This is critical to the efficiency, the running of the valve, eliminates pressure spikes, also helps reduce torque on the gear train. Excessive bypass is not acceptable, but there is a degree of bypass to some extent. You'll see this to be the case with all valves on the market. Okay. The other thing to take note of is the length of time that we actually spend on one port. We call this the efficiency of the valve. So you can see that we're spending a good amount of time on one port. Of course, we can control this with our speed control via the lid of the low profile valve. But you'll see how slowly this transitions when we're off to the next port. Typically in a swimming pool, you'll want to adjust your speed on your valve so that it lasts about 30 to 45 seconds per zone. This will ensure adequate circulation and adequate cleaning for each head in the zone. Okay? So you can kind of see as this cycles from zone to zone or port to port, same difference, we smoothly transition from one to the other. Okay? Alright. We could probably slow this down a little bit simply because we don't have a heck of a lot of resistance in this system since we've got a pump sitting on the deck and no more than a few feet of pipe in the system. In your normal hydraulic system, there would be dozens and dozens of feet of pipe, which equates to head resistance to the system, and it would operate a bit differently, but this gives you a good idea. Okay, so we're going to go ahead and we're going to shut off the A&A valve, and we're going to turn on the Blue Square. Alright. Now, one thing to take note of here is, again, we have a degree of bypass in the closed ports, or the closed zones. Okay, the thing to take note of is the efficiency of the valve. In other words, how long did we spend on one port? Okay, well, you can see right here, we're open on 2 ports. And I'm not going to count during the time that 2 ports are open, simply because I'd be counting for a long time. So we're going to wait, we're going to let it cycle to the next port, and then I'll count. I'll just do a manual count to give you a good idea of how long it actually stays on one port. Okay? So right now we're running on 2 ports. This equates to poor efficiency in your system. You're basically diverting the flow that your pump is providing your water valve to 2 different zones at the same time. Okay, we should be transitioning here soon. We're waiting here. We're starting to shut off. And then what I'll do is I'll start counting as soon as we reach top dead center, or that's another name, another term that I use for full port, or 100% efficiency. Okay, we're getting close. We're getting close. We're getting close. We're getting close. Okay, I'm going to start now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like the other port's starting to open up right now. So I reached about a 10, 11, 12 count. That corresponds to our findings in that this valve is about 10 to 12% efficient. In other words, you're directing flow from your pump to one single port only about 10 to 12% of the time. The other 90 to 88% of the time, you're always sharing water with another port. Okay, so that's the Blue Square water valve. Another angle at it. Okay.